be questions that you're going to see on, most likely on your test, things that are very similar to this. Again, I'm not going to give you a lot of like straightforward, here's a right triangle, here's a rhombus, or here's a square, whatever figure, and say, and provide you the components that you need to do that, right? I'm going to imply some values. So what I mean by that is, throughout this one, there are some implied values here. Would you guys agree that that distance right there would be an altitude? Okay? That's the implied distance that's being provided by that right there. Okay? Now, when I look at that, okay, do we have the ability, with this being 45, to figure out what h is? Because we know from earlier chapters that if I have a right triangle, and this side here is n radical 2, this is n, and that is n, right? And a 45, 45, 90. Okay? So my 5 is equal to my n radical 2 side, correct? So what would n be? 5. If I solve this equation, is it just 5? It's 5 divided by radical 2, isn't it? Okay. And n, would be, if we're looking at our traditional triangle, that is that distance right there, which doesn't that relate to that distance right there in this triangle? So that's our altitude, 5 divided by radical 2. Okay. You can rationalize that now. You can rationalize the final answer here in a little bit. But that is h. What is b? That was b. That's h. What is b for this particular parallelogram? 12. Okay. Remember, your base is always the side that your altitude is perpendicular to. So parallelogram area is base times altitude. So you have 12 times 5 over root 2. Okay. When I multiply those, I always, when I'm multiplying a fraction and whole numbers or integers, I'm going to put that whole number or integer over 1, so that I realize the 12 and the 5 get multiplied together, gives me 60, right? And the 1 and the radical 2 get multiplied together, gives me that. Now, is that my best answer in simplest radical form? No. I need to rationalize this, right? Okay. So multiplied by radical 2 over radical 2. That blue fraction right there is ultimately what number? 1. Okay, and that's why we can do that. We're just multiplying by 1. So it gives me 60 radical 2 over 2. And now, what's going to happen with those two numbers? Gives me 30, right? So 30 radical 2. And whatever unit we're using, that would be square units. Is that all right? So that's where these area questions become a little bit different than what you've done in the past, because in the past, you didn't know anything about special right triangles. Okay, in 7th grade, 8th grade, 9th grade. Now you do, so we're going to incorporate those. We're going to incorporate the new math to address some of this stuff. 17, same question, isn't it? Okay, just different numbers. So I gave you a couple of these things that repeated themselves. That's going to be, essentially 14 times 8 over radical 2. And then rationalize that. 17. Okay, 17. What kind of triangle is that? It's a 30, 60, 90. It's a right triangle. Good. So here's my 60 degrees. And across from 60 is always your what side in a 30, 60, 90? It's your n radical 3 side. This would be n. My hypotenuse would be 2n, correct? Okay. If I look at this, and I want to solve for n because I need this other side, I would take 8 equals n radical 3, divide both sides by radical 3. Cancels, gives me 8 radical 3 is equal to n. Is that all right, everybody? So that's what this side right here is, 8 over radical 3. Again, if you need to rationalize that now, go ahead and do it. You can wait till the end if you want to as well. I always wait to the end, and this is the reason why I don't think we see it in this problem, but occasionally I might, through formula, let's say that in one of my formulas that one of the components was another radical with another radical 3 in the bottom, it would that calculation would automatically rationalize it for me. Does that make sense? So I always wait to the end because there might be some intermediate things here that take care of that process anyways. So I, again, wait to the end. So now, if this is a right triangle, what's the area formula for a triangle? 1/2 BH. Which one of these numbers here would be B and which one would be H? Or what are some options for B? Okay, so if I go 8 over radical 3 as B, what would H have to be? It would have to be 8, right? And then ultimately, my only other option is to flip-flop those, right? Let 8 be my altitude, and then 8 over radical 3 would be my my base, okay? In a right triangle, that and that are both altitudes. By definition, altitudes start at a vertex and go perpendicular to the opposite side. If one of them is the altitude I'm going to use as H, then the other one has to be B in a right triangle, okay? So, again, 3 fractions, so it's 1 times 8 times 8. 64. What's 2 times radical 3 times 1? 2 radical 3. I'm going to rationalize. You can cancel first and then rationalize, but I think then after that, you'll have to cancel again. So I'm just going to rationalize first. I would multiply by radical 3 over radical 3, right? So it gives me 64 radical 3. Now, what is that product right there going to give me when I go radical 3 times radical 3? Okay, it's going to give me 3, and then multiply it by 2 gives me 6, right? So my denominator is 6. What number will divide? Now, we can only divide the numbers that are outside of the radical here, okay? Because what this really means is that I have 64 times radical 3 all over 6. So I can rewrite that as 64 over 6 times radical 3 over 1, or I can rewrite it as 64 over 1 times radical 3 over 6. Does that make sense? Through the use of my multiplication properties, these 3 things all say the same thing. It is more logical to look at that one because 64 and 6 come from the same family of numbers, right? And we can reduce those. What number divides those? 2 will divide both of them, okay? Gives me 32 there, and it gives me 3 there, okay? Now, and this is just, if you would type this in like this, so the way I wrote it would have accepted the answer, and I'm probably going to go back and just maybe omit this question from everybody's points. Because if you type this in, that is the same thing, is it not? Just the way I think I have it programmed, to open it up and look at it, but I think the way I have it programmed in the background is that it wasn't accepting that for some reason. It's the same thing. So that's my fault. Apologize for that. But if you see that question on a test or a quiz, either one of those formats will be fine. Here it says find the area of a square that is circumscribed about a circle. Okay. The circle's radius is 5 radical 3. Probably on a test or a quiz, I'm not going to give you the picture. Okay. So we got to know what circumscribed means. And which shape is circumscribed. Okay. So the square is about the circle. I've always thought it's kind of weird to use that phrasing. It's what we normally use, but I like to think about the word instead of about. Around is maybe a little bit better. And when you think around, you think circular, but it's on the outside. That's the way I think about it. Okay. So it's circumscribed around a circle. So hopefully it gives us this shape. Okay. Now it says the circle's radius is 5 radical 3, right? How many different radii can I put in the circle? I can put in a lot, right? I can put in an infinite number. I can put that one in. That's 5 radical 3. Is that one 5 radical 3? Is that one 5 radical 3? Is that one? Are any of those going to give me information about my square, though? No. Okay. If I do that one, is that 5 radical 3? Does that give me information about my square? Yeah. Okay. And there's quite a few different ways we could approach this. Now, and this is the way I think I would do it, and hopefully you do as well, because this is the most efficient way. If that's 5 radical 3, remember that's your apothem for the square, because the square is a regular polygon. But don't you also know that that radius would be 5 radical 3? Okay. And that distance is exactly the same as a side length. So what is a side length for this square? 10 radical 3, right? We add those together. Okay. So if that's a side length, the area is s squared. So the area would be 10 radical 3 squared, right? Okay. Well, when I have a product and I'm squaring it, we've done this before. If I have AB squared, that turns into A squared B squared, right? That's the algebra. So 10 is my kind of my A object, so I'll square that. And then radical 3 is kind of my B object, so I'll square that. What's 10 squared? 100. What is radical 3 squared? 3. So what's 100 times 3? 300. Not the only way you could do this. I don't know that the other ways are really enjoyable. You know, that is my apothem, right? 5 radical 3. If I think about that triangle right there, it's a right triangle. Okay, take 360 divided by 2n, so 360 divided by 8 would give me that to be 45, right? It's a 45, 45, 90 right triangle. That means that distance there is 5 radical 3, correct? So what does that make one side length here? 10 radical 3. We've already determined that, right? But if I'm going to use the area of a regular polygon as 1/2 the apothem times perimeter, my apothem in this case is 5 radical 3. What's my perimeter going to be? Isn't it going to be 40 radical 3? Does that make sense? Let's multiply that out. What's 5 times 40? 200. So I get 200. Radical 3 times radical 3 is 3. On the bottom, I get 2 times 1, which is 2. So I change to 100 times 3. That's still 300. So you can use that formula. I don't know if that's the best, because on your way to that, you find a side line. If you got a side line, you might as well use side squared. But you have options, I guess is what I'm getting at. Okay, that's good. So you're saying that, and this has to do with what we understand about radii and lines of tangency, or tangent lines, okay? Those are, that bottom red line is tangent there, right? So that's a right angle. That one as well is tangent over here. So that's a right angle. That's going to be a right angle, okay? Or we can kind of go through the work to figure that's a right angle. So you're saying this is 5 radical 3. That is 5 radical 3. Because of these angles and these radii, we have ultimately enough work here to show that this is a rhombus that has two consecutive sides congruent, which means it's got to be a square, right? So Kenzie found the area of that square by taking 5 radical 3 squared. It's 25 times 3, which becomes 75, right? Okay. And then she said, well, there should be 1 more, 2 more, 3 more of those, right? So she took this number and multiplied it by 4, and that gives you 300 as well. That make sense? Okay. I don't know if this makes a whole lot of sense, but let's try it this way. 5 radical 3, right? 30 sorry, 45, 45, 90 triangle. So doesn't that make this distance out here 5 radical 6? This is my n radical 2 side. So what would that distance be? The same. That would be 5 radical 6. So the whole diagonal, let's say diagonal 1, would be 10 radical 6, right? What's diagonal 2 going to be? What's the diagonal that's going in that direction going to be? 10 radical 6. Could I say that area is 1/2 d1 d2? Get 1/2 d1, 10 radical 6. d2 is 10 radical 6 as well. I'm just going to square this like that. And that's going to be 1/2. 10 squared is 100. Radical 6 squared is just 6, right? What's half of 600? 300. Okay. Multiple ways of doing these problems. Okay. Some of you might have even seen, okay, well, if you've got that picture, can we kind of use what Kinsey did, but do it with triangles? Kind of find the area of that triangle. Go 1/2, 5 radical 3 times 5 radical 3, and multiply that by 8. Okay. You have a lot of different things you can try to mess around with there for that problem. Are there ones that are more efficient than the others? Yeah, that first process is much more efficient than anything else. This one is a common question. I put this on tests and quizzes a lot. It says find the exact area of a rhombus with a 60-degree angle and sides of 8. So let me draw a rhombus here. Now, if we know it's a rhombus, we're going to have to use areas 1/2 d1 d2, right? From the given information, this is all I know, and has an angle of 60 degrees, so maybe that one's the 60-degree angle. So would that, right? And we know that through our work, that would be 120, that would be 120, because consecutive angles of a parallelogram have to be supplementary. So that's the information that we get. But I need my diagonals, right? I need D1 and D2's length. So I'm going to draw in D1 and D2. And the reason I like to give this question is because it incorporates a lot of knowledge about your properties of rhombuses, which are things that occasionally we forget. What do the diagonals do to one another? Okay, they bisect each other, so that distance and that distance should be the same. That distance and that distance should be the same. What else? Perpendicular, so there should be a right angle here, right? Okay. What do they do to the angles of 60 and 120? Bisect them as well. So doesn't that make that 30 and that 60? Okay. So now we got 30, 60, 90 triangles, correct? I'm just going to pull out one of those 30, 60, 90 triangles just so I can make so it's a little bit less clutter here. And honestly, guys, it doesn't really matter which one you let be the 60-degree angle. If you wanted this top to be 60 degrees and this one to be 120, it does not matter. Okay, you're going to find D1 and D2 as a product to be the same point. So then if this is 8, that's your 2 inside, right? So this would be 4. And this would be 4 radical 3, correct? So now when I come back to the rhombus picture, that distance right there would be 4. So what would this distance here be? 4 as well. So what is D1? 8. D2, that's going to be 4 radical 3, and that's going to be 4 radical 3. So D2 is going to be 8 radical 3. And like I said, if you flip-flop the angles, you change the 60 to 120, these two things are just going to change. Okay, they're going to flip-flop slots. It doesn't matter. So area is 1/2. 8 times 8 radical 3. 8 times 8 is 64. What's half of that? 32. So those three numbers there are all rational numbers, so I find that product first. And then that rational number times radical 3, an irrational number, I'm going to leave it as that. So 32 radical 3 square units. I can give you the same question, but say instead of the sides being 8, I could say the perimeter is 32, right? And then you go through the exact same process for that question. Is that right? Yeah. Yep. So you could, you know, if you look at this, you could say, the way, just because of the 60s that were provided, we could do that. Okay. And now you know if that's 8, that's 8. Doesn't that make that blue line 8? Okay. Now you have to do a little bit of work to figure out what this distance there was, because that's the altitude of that triangle, which you can do that. Eventually, I'm going to show you guys that there is a formula for equilateral triangles, which is area equals s squared radical 3 over 4, where s is a side. Let's think about this. What would a side length be for that triangle right there? 8. So we'll take 8 squared radical 3 divided by 4. 8 squared is 64, right? Okay. Divided by 4. So what's 64 divided by 4? 16. So it's 16 radical 3, right? How many of those triangles do you have? You have 2 of them. Double that, you get 32 radical 3. Same thing as 1/2 d1 d2 in that case. A lot of options. Okay, the more formulas you know, the more properties you know about shapes and how they relate to one another, opens the door for you to maybe address these problems in different ways. And that's what I think is important for us to be able to do. You've heard me say, don't kind of back yourself in a corner. Don't pigeonhole yourself. Don't say that I can only find this quantity one way. Because what if you're not provided with the information that allows that one way? What are you going to do? Okay. So opening the door, giving yourself more skills, and more approaches is going to be very beneficial, kind of in the long run. So this is the same thing. Is it the same thing? I don't know. Yeah. So let's see if this really changes anything. Let's say that find the area of rhombus with the side of 17 and the longest diagonal is 30. So not my rhombus needs to be that big, but all right. So if the longest diagonal is 30, could that be D1? Okay. And this is where we need to understand our properties of diagonals. We understand that this, we use the horizontal one to be the longest one. If that was 30, what would this distance right here be? 15. That's 17. You know that these are perpendicular, right? So which theorem should hold for you to be able to find that? Pythagorean theorem. Okay. So we should be able to say 15 squared, which is 25, plus let's just call this x. 2.5. I wrote 2.5. 15 squared, 2.5, plus x squared. Anybody know 17 squared? Why not? 289. Okay. What's 289 minus 2.5? 64. So x has got to be 8. So what is diagonal 2 if x is 8? 16. That's the place that most people make a mistake in these problems is once they find x, they forget to double it. Okay, you need the entire diagonal. So then we go 1/2 d1 d2. What's easier? 15 times 16 in your head, or 30 times 8? 30 times 8, because 30 times 8 you can do by 3 times 8, right? Which would be 24, and then you tack on the 0, so it should be 40. Is this okay? All right. Was this one hard? Should be. base, so perimeter of 32, each side length is 8, right? And then you now have side length, so I square that to get the area. So 64. Diagonal of 3 radical 2. Okay? This is where, a lot of people, like I said, pigeonhole themselves and saying area of square is S squared. But if I understand that a square is also a rhombus, doesn't this question get pretty easy? 1/2 diagonal is 3 radical 2. And I square that because I need 2 diagonals, right? And they got to be the same in a square. So now I have 1/2 9 times 2, right? And half 2 is 1, so I got 9 times 1. So 9 squared units. Yeah, stop. Isosceles triangle with a base 12, perimeter 32. Isosceles triangle with a base of 12 and a perimeter of 32. So that means the side lengths have to be terrible isosceles. Morning, Anita. Okay. If that's 12, that's got to be 10, and that's got to be 10, right? All right, so you can use any one of these. If we're going to go 1/2 BH, you can use either one of those as your B, right? Which one do you think makes most sense to use as B? 12. So now H would be from the vertex opposite straight down, right? Okay, and it's got to be perpendicular down there. What do I do in order to find out that H? Okay, good. So it makes that little distance right there 6, because we know that this segment should be perpendicular bisector of the base. So that's 6, that's 10. Pythagoras tells us this should be 8. Okay, 6, 8, 10 is a Pythagorean triple. So there's my H. Okay. 12 times 4 is 48. Is that right? Huh? All right, so here's another question. So this is not very insightful. It's the same triangle, right? So it's the same answer. But when we see 6, 8, 10, or eventually I might say 3, 4, 5, or I might say 12, 16, 20. Okay, these are special types of triangles. These are all right triangles. So if those are all right triangles, which ones have to be B and H? 6 and 8. Those are the only ones that can be B and H, because those are the only ones that are altitudes, right? The largest one has to be the hypotenuse. So you take 1/2 6 times 8, and there's your area of that. Okay. So hopefully those. Well, and we're going to see more and more types of questions like that throughout this chapter. See some today with trapezoid.